This video is all about section 9.2, which is called truth tables. The main question we want to answer here is, how do the truth values of things like not P, P or Q, P and Q, depend on the truth values of the statements P and Q? So let's start off talking about not P. And we're going to build what's called a truth table here. So we're going to list the possible truth values of P, which would be either true or false. And beside that, we're going to list the truth values of not P. So remember, the way we write not P is just tilde P, like that. So since not P is the negation of P, the truth values of not P are just going to be the opposite of the truth values for P. So if P is true, then not P is going to be false. And if P is false, then not P is going to be true. So this object here is called a truth table, and it helps us answer the question as to how the truth values of not P depend on the truth values of P. So we're going to do a similar kind of truth table for our other two operations. We're going to talk about P or Q, and after that we'll talk about P and Q, and we'll just make sure we're comfortable building truth tables for those types of operations. So let's start with P or Q. P or Q involves two different statements, P and Q. So we're actually going to have first two columns here representing what's going on with P and Q, and then we'll be able to write our P or Q operation. So or is written like that. And we're just going to fill in the possible truth values for P and Q. So since we've got two statements and each of them can be either true or false, if we think about how many rows are going to be in this table, there are going to be 4 rows. We're thinking of that as 2 times 2. 2 possibilities for P and 2 possibilities for Q means 2 times 2, or 4 possibilities overall. So the conventional way to do this is we let both of them be true, then we go true, false, false, true, false, false. And if we all fill in our truth tables in the same order, then we'll all get the same truth table coming out as a result. And that's really helpful if you're, say, checking your answers for your suggested homework. So conventional to always fill it in that order. Okay, now let's think about P or Q. P or Q is going to be true if at least one of the statements is true. So if both P and Q are true, then P or Q is true. If only one of them is true, P or Q is still true. The only time P or Q is false is if both of your underlying statements, P and Q, are false. So the way I would summarize this is I would say P or Q is true when at least one of P, Q is true. So that's just a verbal summary of what we're saying in this truth table. So if you're saying something like, Paula or Quinn went to the party, that would be true if at least one of Paula or Quinn did actually go to the party. It would be false if neither of them went to the party. That's essentially what that's saying. All right, so let's talk about the third operation, P and Q. So again, we've got 2 different statements, P and Q, coming up. And then we're going to think about the AND operation, which is written like that. And again, we need 4 rows in this table just to account for the 2 times 2 possibilities for the truth values of P and Q. So we'll fill this in the conventional order: true, 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 false, false, true, false, false. We always do it in that order just so that it makes it easy for us to compare answers if we're checking our answers with the course pack, for example. And so let's think about the truth values of P and Q. Say, for example, you said something like Paula and Quinn went to the party. So that would be true if the statement P, Paula went to the party, is true, and if the second statement Q, Quinn went to the party, is true. So they would both have to be true in order for the AND to be true. In every other situation, P and Q is going to be false. So we could summarize that by saying P and Q is true when both P, Q are true. And so that's a verbal way of just digesting what we've got in that table. Okay, so we've now seen the truth tables for P and Q. We've seen the truth table for P or Q. We did that up here. And then we did the truth table for not P. So those are our three basic truth tables that we've got so far. And we're actually going to see one more operation before we get into some bigger examples. So our last operation that we're going to look at is written like this. So the operation itself is like a plus sign with a circle around it. And what that represents is P or Q, but not both. And when you read that, you can say P exclusive or Q. Or some people call that XOR. You could say P XOR Q, which is just a fast way of saying exclusive or. So when you write this, it's sort of like an OR operation, but it's excluding the case where both of the underlying statements are true. So let's see if we can build a truth table for this operation. So I'll call this P XOR Q. We were writing it in words, and we would build our truth table in the usual way. We're going to talk about our truth values of P and Q, and then we're going to write down the truth values of this new operation, P XOR Q. All right, so filling in our truth values in the conventional way, we go true, 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 false, false, true, false, false in that order. And according to our definition up here, which I'll just put that in a box, let's label that. That's our definition where we introduce some notation and we define what this exclusive OR means. Let's think about it. So P XOR Q is going to be true when exactly one of the statements is true. So it'll be true if P is true and Q is false. It'll be true if Q is true and P is false, but it's going to be false if both things are true or if both things are false. Because we want to exclude the possibility where both things happen. So if both statements are true, you make that false. And that's how that's different than the usual OR operation. All right, so let's see if we can summarize this. We would say P XOR Q is true when exactly one of PQ is true. So when exactly one of your underlying statements is true, then the XOR operation will be true. All right, so those are the four basic truth tables that we're going to be working with today. And our goal is to build some truth tables for some more complicated statements. And this is really helpful when you're analyzing a compound statement that has a lot of different parts. You can use a truth table to boil it down to something relatively simple, where you can understand what the truth values of your statement are going to be depending on what the truth values of the underlying statements are. So here's our first example along these lines. We are going to build the truth table for the following operation, or the following compound statement, you could say, not P and Q. So we want to understand the truth values of not P and Q based on the truth values of the underlying statements. Okay, well, we see two statements, two simple statements in this compound statement. They're P and Q. And whenever we have a setup where there are two different statements, P and Q, coming up in our compound statement, we know we're going to need 4 rows in this table. So if we want, we can start just by doing that setup, the true, 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 false, false, true, false, false. So by doing that, we know we've covered all 4 possibilities, all 4 combinations of what the truth values of P and Q could be. And once we've done that, then let's think about how many columns we're going to need in this truth table. When we get into some of these bigger compound statements, you might need a few columns of intermediate work before you can really get to the compound statement that you're trying to build. So I would think about order of operations here. I would start inside the brackets, and I would first figure out what P and Q looks like. And then once we know what that looks like, then we can negate those truth values. Okay, so that's how we'll do this one. So let's do P and Q. So we know P and Q is going to be true when both statements are true, and it's going to be false in every other situation. Now for the last column here, what we're trying to do is negate the truth values of P and Q. So we're just now looking back to the previous column, and what we're supposed to do is flip the truth values so that we're actually negating those. So false, true, true, true. So now we have an understanding of what the truth values of our compound statement look like. Here they are. And we can figure out in which situations that compound statement is going to be true and in which situations it's going to be false. So over the course of this video, we're going to do 3 more examples and just get used to this idea of building truth tables for a variety of compound statements. All right, so let's jump into our second example. Let's build the truth table for the following. Let's do P XOR Q or P and Q. So first thing I would ask myself is just how many different simple statements do I see all across this statement here? As I look at this big compound statement, I just see P or Q. Those are the only symbols that I see. So we're going to have some columns for P and Q. And since there are just 2 simple statements that come up here, we're going to need 2 times 2, or in other words, 4 rows in this table. Okay, so we'll do true, 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 false, false, true, false, false, like that. And then we'll work our way systematically up to this compound statement. So if you look inside the brackets, some of the things we'll need to calculate are truth values for P XOR Q. We'll need truth values for P and Q. And then once we understand truth values for those 2 statements, then we can perform the OR operation that's going to join them. So then we'll be able to do P XOR Q or P and Q, which is what we're ultimately after. Okay, so let's just work from left to right here. We're going to start with this column where we do P XOR Q. So remember, P XOR Q is going to be true when exactly one of your statements is true. So it'll be true in those 2 situations, false in the other 2. Okay, now let's move on to P and Q. So we're looking back at the truth values for P and Q, which were over here. And we're going to perform the AND operation. So that's going to be true when both statements are true, and it's going to be false in every other situation. Okay, and then last thing we need to do, we need to perform the OR operation on these 2 columns here. So we need to be looking at the column for P XOR Q, which is here, looking at the column for P and Q, which is here, and think about joining them using the OR operation. Okay, so the OR operation is going to be true when at least one of your statements is true. So be true here, true there, but false in the last situation where both of our truth values are false. So there we go. We've got our truth table for our compound statement. So that's about as complicated as it's going to get with 2 simple statements in the question. But we're now going to look at a couple of examples where we've got 3 simple statements coming into the discussion. Okay, so let's build the truth table. For the compound statement, let's do P and Q or R. So the first thing I would point out here is that we've got three simple statements coming up in our compound statement here. When we say simple statements, we're really just talking about the different letters that we're seeing. So P, Q, and R that represent different pieces of information. Okay, so because we've got three simple statements, and each of those statements can be either true or false, if we think about how many rows we're going to need. 2 rows to account for the two truth values for P times 2, well, let's just talk about the number of rows that we need. So 2 possible truth values for P times 2 possible truth values for Q times 2 possible truth values for R overall gives us 8 different rows that we're going to need when we build this truth table. All right, so let's think about how we would start to set this up. I would write down P, Q, and R as the starting point here. And this is our first example doing one of these compound statements where we've got 3 simple statements in place. So I'll just show you generally how you set up the table in this context. So you want to write out 4 trues and 4 false for P. And then within these top 4 rows here, just think about now we need to capture all the truth values for Q and R. So within these columns here, we're going to set it up similarly to how we did in our previous example. So you go true, 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 false, false, true, false, false. So that captures all the possibilities where P is true. And then for all the possibilities where P is false, you want to do exactly the same thing again. So Q and R could be both true, could have true, false, false, true, false, false. And that's the conventional way to set up these tables. When you are checking your answer in the back of the book, you will see the truth tables set up this way. So pretty important for the sake of being able to check your work that you do it in this particular order. Otherwise, it's just hard to check. Okay, now let's think about systematically building some columns in this table. So we'll go back to this compound statement that we're trying to build. Let's start inside the brackets first. We could build a column for P and Q. And then once we had that, we would be able to do P and Q or R. All right, so I'm just going to erase some of the clutter here. Might be a good idea just to keep, sometimes I like to keep a horizontal bar just halfway through so that the rows don't get too out of whack when we're reading this. Okay, so let's do P and Q. So P and Q, let's look at the columns for P and Q here. It's going to be true when they're both true. So true, true, false, false, and it'll be false definitely in every situation here where P is false. So that's our column for P and Q. And now for our last operation, we need to make sure that we're looking at the correct columns. So we need to look at the columns for P and Q and for R. And we're joining those guys using the OR operation. So remember, the OR operation is going to be true when at least one of our columns has a true in it. So it'll be true here, true, true, false, and then true, false, true, false. So because we're doing an OR operation in this last column, the only time we'll see false is when both of our columns here had false in them. So that happens here, there, and there. So there are 3 positions where we're getting false. In every other position, we're getting true. So that's just a little double check on our work there. All right, so what this allows us to do then is now understand the truth values of this compound statement, the P and Q or R, in terms of the truth values of the simple statements P, Q, and R. So we're going to do one more example along these lines. We'll do a bigger example, and then that will wrap up section 9.2. So last problem, let's build the truth table For the following compound statement, we're going to do P or Q, exclusive or. Going to double bracket here, P or R and not P. Close our brackets. Okay, and I'll just put a question mark there so that we're asking the question. So let's build the truth table for this thing. I'm intentionally choosing something somewhat challenging so that we can get some good practice with these truth tables. So first thing I would ask myself in this type of problem is just how many symbols are we seeing as we look across the compound statement? How many different letters are we seeing? Well, P, Q, and R. So that's what tells us that we need 8 rows here. You've got 2 possible truth values for P times 2 possible truth values for Q times 2 possible truth values for R means we're going to need 8 rows to capture all the possible combinations of truth values. So we'll start off with our columns for P, Q, and R. We'll focus in here on how to set up the truth table, and then we'll figure out what our columns should look like. So remember the conventional way to do this when you have 8 rows. You just write down 4 trues and then 4 false. You can draw a horizontal line through this halfway through if you want. And then we need to capture all the 4 possibilities of truth values for Q and R. So we usually go true, 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 false, false, true, false, false. And then same thing again for all the possibilities where P is false. So true, 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 false, false, true, and false, false. Great, so once we've got our table set up, then we can think about what we want our columns to be. So we can think about working inside the brackets here. We're gonna need P or Q. And then if we look at the second set of brackets, so I'm looking particularly over at this part now, in the innermost brackets we have P or R. Then we could figure out not P. And once we had those two, then we could figure out the entire P or R and not P. So we could figure out that part. And then once we had that, then we would have everything we need to actually give our full compound statement, which is P or Q, X or P or R, and not P. So that will be our last column there. Oops, just resizing that a little bit so that that's easier to see. Okay, so it looks like we're ready to get started. I'm just checking that we've copied everything down properly, so making sure that this entire compound statement here is exactly what we've got here, and it is. So we've set this up in the correct way. Okay, so let's do this systematically from left to right. So we're going to go P or Q. So just look at the columns for P and Q, and this is going to be true as long as at least one of them is true. Be true, 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 and then false. Oh, sorry. It's going to be true all the way down because P is true in all those positions. So true, 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 true. And then as we move down here, it's going to continue to be true anywhere that Q is true as well. So the only time it'll be false is when both P and Q are false. That happens in those bottom 2 positions. Okay, next we're going to do P or R. So let's make sure that we're looking at the columns for P and R. So first and third column. And again, we're doing the OR operation on those 2. So it's going to be true as long as at least one of them is true. Will definitely be true everywhere P is true. And then we get true, false, true, false. So the only situations where it's going to be false is where both P and R are false. And there are 2 situations like that. Okay, next column, let's do not P. So we're looking back at the column for P, which is the first column. just flip all those truth values. So we get 4 falses and then 4 trues. And now we're getting into the home stretch. So the next operation that we're going to do, we're going to look at the columns for P or R, which is this column, and not P, which is this column. And we're going to perform the AND operation on those 2 columns. So remember, the AND operation is true when both statements are true. So we're going to have false in the top 4 positions. We're going to have true, false, true, false. So there are only 2 rows here where this is going to be true. It's in the 5th and the 7th row where both of our statements are true. Okay, and then very last column to finish off this truth table. If we look at this highlighted compound statement here and figure out what it is that we're trying to build, we're going to need to look at the column for P or Q. So that's this guy, as well as the column for the compound statement P or R and not P. So those are the 2 columns that we now care about, and then think about what operation we're doing. Xor operation. So remember, Xor is going to be true when exactly one of our statements is true. So be true in all the top 4 situations where we're seeing true and false. Will be true there. And then as we go below the horizontal line, if they're both true, Xor is false. If one is true and one is false, it's true. True again here, and it goes back to false when both of our statements are false. So that is what I would consider a challenging truth table for a compound statement that has 3 simple statements involved in it. So we've seen how to build these truth tables. We now have all the skills we need to build truth tables with 4 or 8 rows, depending on whether we've got 2 or 3 underlying simple statements in our compound statement. So remember, the whole point of this is it allows us to take a statement that's quite complicated, something that you might see in a legal document, for example, that has a lot of or, and negations in it. It allows us to break it up into simpler statements and really analyze in which situations is our compound statement going to be true and in which situations is it going to be false. So that's the end of our discussion on truth tables. Thanks for watching.